Okay, basic concepts of computers. I'm Anajit Tharuratna from the IT Center. Under this course, we are going to talk about the basic concepts and fundamentals of the computers. Uh, Under these titles, computer and computer types, hardware, software. There are some categories under this software title: system software and application software, and then computer generations, then computer types. uh, Computer fundamentals. Okay. Computer is a system or machine or electronic device, and it can perform complex tasks by breaking them into simple calculations and doing them quickly. That is kind of a definition of a computer, and we can define the computer in various ways. And the base is it can perform complex tasks by breaking them into simple calculations, and also it is faster. That's the expectation of building a computer. And the functionalities, the functionalities of a computer can be simply like this. Takes data as input and stores the data instructions in its memory, and can use them when required, and process the data and convert it into useful information, output the information, and control the above four steps. That means we can list out the functionalities of computer as simple as this. It is a device that takes data as input, and it stores the data or instructions in its memory, and it uses them when they are required, and it processes data to get output, and it convert it into useful information. Also useful means human readable. Okay. That means it is in a way that can be understood by the humans. Output the information and control all the above four steps. Computer must have the ability to control all the above four steps. Now, in earlier computers, it didn't have that much of control about all the systems. We have to control the input, and only the calculation or processing part will be is done by the computer, and we have to control the output, and we have to convert it into a human readable format. Okay. And what we expect or what we get from a computer, we expect or we get we can use these words: speed, accuracy, diligence, versatility, storage capacity. uh, Speed, we know that obviously computer, we can, if we have a program or design the software to do something or perform a task, then we can get the output as quickly as that particular program generates the output. Okay. And there's a sort of scale in millions. Okay. About 3 to 4 million simple instructions can be performed in within a second. Okay. And accuracy, if that particular program is designed to achieve 100% accuracy, then we don't have to worry about the accuracy. The only thing is, as the software designer is a simple person like like this, like us. Then it totally depend on that particular person. When we talk about this accuracy, if you want to achieve 100% accuracy, then he or she has to design that particular program in a way that it generate the output with 100% accuracy. Okay, diligence. Now most of these are mentioned comparing with a person or a human. Now when we are working, if we work continuously, then after about 2 or 3 hours we get tired, then we get bored, and then because of that we lose the concentration. Then it affects on the accuracy and the speed. So the computer doesn't have that kind of problem. It can perform the task continuously. And versatility, the computer can perform tasks as long as it can. That means a certain period of time, an hour, a day, year, or more than that. And storage. Now when you compare about our current storage solutions in stationary based, we know that we have to use papers, then folders, large logs or books, and to store them we have to use racks, cabinets, and room, floor, building, like that. But in a computer it only takes about 6 cubic inches. In that we can store unimaginary amount of data. It depends on the complexity of that particular data set. And when you talk about these storage devices, it has kind of unimaginary, kind of limited. But when you consider about data, it can store large amount of or huge amount of data. And this is about the hardware related with your computer. And to build a computer we have to use these physical devices. We have to assemble them together or combine them to assemble a computer. First one is input unit. For this input unit there are so many input devices. The basic input devices are mouse and keyboard. Earlier it was only the keyboard. Now we have some other devices like video cameras, game consoles, and some devices like scanners and digital cameras. And we have a mic, and also here you can see another device. It is called a kind of a touchpad, which you use with your laptop. Instead of the mouse, there's a built-in device called touchpad in a laptop. Now this device is kind of a touchpad, and also with that there's a kind of a device like a pen. It is called stylus, and it is designed designed to use in computer graphic areas, that means for designing, like this. With those graphic design applications, we can use the mouse, but the thing is, we can't actually get the exact flowness of our hand by using a mouse. That flowness, to get that flow, we have to use a pencil, pen or paintbrush. So by using this stylus, we can actually feel like that we are using that kind of device, like a pencil or brush. So in graphic design applications, instead of using a mouse, they use this kind of touchpad. Also nowadays it comes with touch touch screen, or that means the input and output devices are as a single unit. Okay. And the next one is output unit. These are the devices that we get the output in kind of human readable or human understandable format, and from this output unit we can get the output as a sound on the screen, like this, and as a hard copy by using a printer like this, as a sound, as a light, using a projector, projecting the output on a surface. And also now we have 3D printers to print an actual physical model by using a device like this, by using a set of raw materials like plastic. And here we have touch screen monitors. It also act as input device. We can use our finger, and also, as I mentioned earlier, with the stylus, it can use also on this screen, like actually we are drawing on a paper. Only difference is it is a screen. Okay. And the next one is memory unit. Okay. These are the devices that we use to store programs or data on a computer. There are devices, some devices store data on temporary basis, some on a permanent basis. And to measure the amount of data that can be stored, or that is stored in a computer, and the size of that particular data set, we have a scale. The smallest one is called bit. Okay. Then a chunk of 8 bits is called 1 byte. Then it will be multiplied by 1024 and labels as like our metric system. And 1024 bytes is equal to 1 kilobyte. Then 1024 kilobytes is 1 megabyte, and giga, tera, peta, like that we can build the scale. So we use this to state the capacity of this particular storage devices, and also to mention the size of a data set. Okay. That means size of a file. In a computer everything is file, so data is also saved as a file. Then the file size is also mentioned by using this scale. And this is the memory organization, or how memory devices are arranged in a computer, and every set of data flows from this top to this bottom, or from bottom to this top. And you know that in a computer there's a device called CPU, or central processing unit. We call it as a processor. It lies here at the top of this one, this pyramid, but not included in the pyramid. And it is at one of the end of this data flow, the processor, and here the other end, it can be a memory location called CPU register, cache, main memory, secondary storage, or input sources. And CPU registers means now you know that in a computer we have a memory called RAM. Now in this processor or CPU in the computer, it also has a dedicated memory or RAM. It is called CPU register. And also there's another set of memory called cache. It has more than a single level, or more than one level, like level 1, 2, 3. And then for you can find the main memory or RAM. And you can, in a computer you have physical RAM, which we build using RAM modules. Okay. Also it uses virtual memory, which is part of our hard disk or the secondary storage. Then secondary storage, there are separate chips and removable devices like pen and network or internet storages and hard drive. And input sources, they also send signals through these or this memory devices up to the processor. Now this in this memory organization, you can see a kind of a pyramid shape. Now at the top of this pyramid, there lies the fastest set of memory. Those are the CPU registers. Then the cache, it is slower than CPU registers. Our RAM, it is slower than this cache. And our hard disk, it is also slower than main memory. Okay. And also when you reach to the top of this one, the price of this particular memory unit or memory device, it also higher. That means CPU registers is in a higher rate of cost. And the second one is cache. Okay. That's why sometimes we can get 1 terabyte of hard drive and about 16 GB of RAM for the same price. And classification of memory, we can classify memory into two, primary and secondary. Primary memory are registers, cache, and main memory. They are internal to the computer, or they are placed on the motherboard. And secondary memory, they are external to the computer. They have a large capacity and also permanent storage devices. They are attached to the computer by using a cable. Okay. And primary memory can be divided into two: RAM and ROM, random access memory and read-only memory. This RAM is the memory module that used by the processor. It is a temporary memory, or we call it as a volatile memory. We lose the content when the computer is shut down or power off. Then it is a read and write memory. When the computer is working, it is being used. ROM, permanent memory, non-volatile. There are contents when you shut down the computer. It won't be erased, and it is read only. This kind of memory type is used for a special purpose, to like storing startup instructions or booting instructions. Okay, that means when you boot up the computer, there are some settings need to be configured, and there are some default settings like checking the RAM, like that. There are some post or power on self test. Those instructions are stored in this ROM memory. And cache memory, it is a high speed memory. It can be a reserve section of CPU, or that means it can be built inside the processor, or it can be an independent storage device or a chip on a motherboard. It is kind of a path between those other memory devices like RAM, and the processor. By using this cache memory, it speed up the data flow. Okay. And this is how those cache are organized in a processor or in a computer. There can be a single processor and two cache levels, two processors, two cache levels dedicated to each. And like this, two processors, level 1 cache, both cores have separate level 1 caches but shared level 2 caches, or like this, separate cache levels. And here I have 4 core, that means 4 processors. Okay. Then up to level 2, they have their own cache levels, and level 3 is shared, and this is the RAM. So the data flows from other device like hard disk to the RAM, then to level 3, then level 2, level 1, then to the processor. Again, if it write back to the hard disk, level 1, level 2, level 3, then to the RAM and to the memory device. And secondary memory, this is the most common storage device. Here we have magnetic media like hard disk, magnetic tape, floppy disk, and old mechanism. Most of these devices uses this magnetic method to store data. And optical media, CD-ROMs, DVD, Blu-ray discs. We use laser beams to write data on a metallic plate. And this magnetic media, we have this kind of metallic plate, and there are heads that moves along the radius and writes magnetic signal onto the metallic plate. Now in this optical media, the plate is using plastic, and there's a metallic layer. a thin metallic layer. Then by using laser, a pattern will be drawn on that surface. And flash drives, the most common device that we use to carry our data, like flash drives, USB, or pen drives. The mechanism is similar to RAM but non-volatile. That means if you unplug that pen from the computer, you don't lose the data. In a hard disk, it uses this kind of a pattern to store data. The hard disk will be divided into this kind of tracks, then into sectors, and in that sector there are three parts: header, data, and trailer. By using that reader or writer or head, it will store magnetic charge like this structure. Okay. Then by using the same head, we can convert it back in a way that computer can understand. So there's a kind of intermediate mechanism to convert it into magnetic charge and also understand the magnetic charge, or decode, encode, like that. And when you talk about this secondary storage or hard disk, now there are two types: SSD and HDD, hard disk drive and solid state disk. Okay. And in this HDD, we have a metallic plate like this, and we have a reader or head or arm. By using this arm, we usually read or write data from this plate or onto this plate. And this since it has a kind of mechanical structure or system, it is kind of vulnerable. That means by accidentally, if you drop your hard disk drive, there's a chance to lose the contents or the data inside that hard disk. Now we have this kind of hard disk called solid state. That means there are no this kind of metallic plates and motors or heads. There are only chips like in our pen drive. Okay. And there are this kind of performance or the characteristics. When you consider about characteristics of those two types, there's a huge gap. Okay. Now this access time, that means the time it consumes to access the data from that particular storage device. In SSD it is about 0.1 millisecond. Now in HDD it is about 5.5 to 8, and within a second it can perform random input and output performance up to 6000 in SSD, but in 400 in HDD. And reliability, there's a huge gap, and energy savings 2 to 5, and in HDD 6 to 15, because it has a motor. There are about two motors, one to rotate the plate and the other one to handle the head. And CPU power, that means since it is a hardware device, it need to be controlled by the computer, that means by the processor. if it is need to be handled by the processor, that means it has to use the power use a percentage of part of from the total capacity of the processor. And here it says about 1% of that CPU power is being used by the SSD, while it is 7% in HDD. Like that, there's a huge performance gap between SSD and HDD, and it is also ideal, that means more suitable SSD for portable systems like laptops, and it is very quick and also easy to install. The only thing is the price gap. We can buy 1 terabyte of HDD, and for the same price we can only buy about 250 gigabyte of SSD. Okay. And now in our computer we have only one hard disk, one secondary storage. I'll consider it as a hard disk. It can be SSD or HDD. Okay. And we have a single hard disk. That means if something happened to that particular hard disk, all the data can be lost. And also when you consider about the capacity, it can be about 1 terabyte. Okay. Now let's say I want to expand it up to 4 terabytes. The thing is, we have to buy 4 terabyte a hard disk which has capacity of 4 terabytes. For instead of that, we can use this kind of device, disk array. By using a disk array, we can build larger storage capacity by using smaller hard disk. Okay, that means this is not a this is a separate device. It's called disk array, and it can be connected to the computer. Most of the time these devices are used in servers. Okay. Now you can see in this device, you can see these are the hard disks. They have kind of a lower capacity, and collectively they build a huge storage capacity. Okay. In addition to that, providing higher larger storage capacity, this particular device can protect our hard disk or the content or the data. Okay. And here we have a device like that. Here you can see there are some indicators. Okay. Data indicator and also space used. Okay. The percentage or the scale to mention the currently usage. Okay. And also by using these indications, you can see the health of this particular hard disk. If it is green, that means it is totally healthy, but if it is red or another color, that means you need your attention. You have to pay attention to that device, and it indicates by using red you have to replace the hard disk. Okay. Now In our computer we also have about 4 ports to connect hard disk. That means for our personal computer we can connect 4 separate hard disks, but they act as separate hard disks. We can create partitions, but collectively they don't provide a large capacity. But in this disk array, it let's say now here it has 5 hard disks. If we use 5 1 terabyte hard disks, then collectively by using this disk array it will show as a single 5 terabyte hard disk, not separate 1 terabyte hard disks. As a single 5 terabyte hard disk, we can partition it according to our preference. We can create 2.5 terabyte 2 partitions like that. And also if a certain hard disk is going to fail, then by using this by this system it will identify that, then the data of that particular hard disk will be copied to another hard disk, and that particular hard disk will be isolated and also will be indicated by using these indicators that we can replace it. Okay. Like that, if our data or our files are sensitive or means very important, then we can use this kind of device to protect and also to develop a larger capacity and also with additional protection. And also in earlier disk arrays, to replace a hard disk we have to shut down the computer or the server. Nowadays we don't have to shut down the computer. Simply while it is running we can remove the hard disk and we can replace it by another. And in addition to that, now all those memory devices are local. That means built in our computer or attached to our computer. Nowadays we have cloud storage. That means a remote storage solution. Means the physical device which provide that storage solution is in another location, okay, or in another country. We can get the service from that device, and though it's called the cloud storage, we can get many services. The simple one is the storage. That means we can save our files inside that storage location. And we are already using this kind of cloud storage with our email account, with our phone. Most of the time with those devices it comes with cloud storage package like Google Drive and also OneDrive with Microsoft. Like that, there are many cloud storage which comes with devices, and also we can buy storage. And there are some advantages on this with this storage solutions depending on the maintainers. That means we don't have to worry about the maintainers. If we have an internet connection, then we can access anytime. And also we can get free cloud spaces by using our email account and some devices. And also there are some websites, they provide storage or cloud storage like Cedar SEEDR.cc. We can upload files, or we can download some files into that cloud storage. And more than that, nowadays we can get a virtual computer, and also we can install an application or a software. We can build a database, and we can create a server from this cloud storage. Instead of buying a computer, we can specify our requirements, and we can request from this cloud storage company. Then we can buy it. Then we can connect with that server by using our internet connection. Then we can build a web server, anything like that. Okay. The CPU, it is the we call it as the processor. It is built on the computer, and it carries out the instructions of the computer program by performing the basic arithmetic, logical, control and input output operations specified by the instruction. That means all the processing will be done by this processor. And the speed is measured by uh, a scale called hertz. Now it is in mega or giga scale, and you can clearly see it is placed on the motherboard, and also a cooling fan to cool or to reduce the temperature. And this is called as the brain of the computer. And ICO, integrated chips, means consist of millions of uh, transistors. And nowadays, while it is seems to be a single processor, but inside that processor there are multiple processors or cores, 2 4 like that. Okay. Then now collectively we can build the computer by using memory device, motherboard, CPU and some other input output devices. When we consider about connecting those devices, these are the ports and connectors we use to connect our input devices, output devices and memory devices. And also nowadays we have network ports or Ethernet port, okay, to connect with the network. And here we have many of the ports available in a computer. These are power cords, and these two are network ports, Ethernet or RJ45, the legacy for network port. And also if it is a modem, earlier we used modem, we can connect our telephone connection with this port called RJ11. And we have some vendor or manufacturer based VGA ports. This is the legacy VGA port, and also Super Video HDMI, now widely used nowadays. Widely used we sorry Nowadays we are using these HDMI ports for to connect this additional display device like projector, and also like external camera, video camera like that. and also you may see some kind of these digital video interfaces. Sometimes we have to use converters to connect with our monitor, and there are serial port. Nowadays we use these to configure some things. Earlier we did have serial mouse, keyboard, and these two are dedicated ports to mouse and keyboard, and parallel port and old mechanism to connect printers. And here you have those audio ports. Serial port, this is the physical view of that. We use this to connect communication device like modem or mouse or keyboard. Parallel port to connect printers, CD writers and hard disks. And now we have universal set of ports called USB, universal serial bus, to connect everything: pen drive, mouse, keyboard, and sound input output. Everything can be connected using USB port, and PS2 dedicated ports to mouse and keyboard. And we need to talk about this wireless. It uses infrared and Bluetooth. Infrared is kind of an old mechanism. Also nowadays only used in this remote controllers, and also in our many modern smartphones. Again, they provide this infrared port to install remote control application to control TV, AC, like that. Okay. And instead of that infrared port, now we have Bluetooth. By using this Bluetooth mechanism, we can connect many input and output devices, but only disadvantage is the radius. Okay. To gain the maximum out effectiveness, we have to be in about 5-meter radius. That means it's not connected with a cable, but you can't leave a huge gap between the computer and that particular device. It should be within 5 meters. And those are the computer hardware or physical devices that we need to assemble or to build a computer. Then after building the computer, we have to use some other set of component called software. Okay. And software is the set of programs or instructions. It is defined to perform a kind of a task, a well-defined function. And there are two types of software: system software and application software. And system software is designed to perform kind of operational steps like controlling. And system is we can find system softwares categorized under these labels: operating system, compilers, interpreter, and assemblers. These are the system software types which makes you this particular interface that can be used to perform any task. and it will control your hardware devices, the processor, memory, hard disk, and other input and output devices, and act as intermediate devices to translate from the data from one form to another, like magnetic signal to kind of these letters. Okay, to read a file. Now read is a magnetic signal. A file is a magnetic signal which has stored on a hard disk, and by using this set of uh, system software, it makes us possible to read that particular file like this. And other than these softwares, operating system, okay. This is the particular software which lies on the top of this system software collection, making a kind of an environment to interact with the computer. That means the operating system builds the interface which we uses to interact with the computer. And there are some operations that need to be done by this operating systems to make it usable for the user. And you can see in this stack, at the top we have user or us, then applications, that means the programs that we use for our day-to-day works, and just below that it lies operating system. Okay. That means without this operating system, these applications can't be performed. And you can see hardware. Under this operating system it lies hardware. That means without hardware we can't install operating system. Without operating system we can't install application. Without these three we have nothing to do. Okay. And by this operating system, which providing us an environment to use applications, there are some things need to be done. In technical terms we can mention them as memory management, processor management, device management, file management, security, job accounting, control over system performance, and interaction with the operators, error detecting aids, coordination between other software and users. Now in memory management, you know that there are many memory devices, RAM, cache, secondary storage. They need to be managed, and to make it enable or to maintain the efficiency of this computer, those memory devices need to be managed properly. Now for that, you know that there are some mechanisms like virtual memory. Now let's say in our computer it has only 2 GB. Okay. Now you know that with that amount of memory we can use a limited set of programs, and to provide efficiency in that particular computer, this memory management is a kind of critical. That means now we are using a software, it uses 100% of your available memory, but we are not aware of that, so we are going to open another application. Then it will take some time, then we can see that the second software is loading. Now while that particular amount of RAM which was available was totally used by the previous software, also it makes us unable to use the or open the second software. That is a part of this memory management. If we request to open another application or software by this memory management, it moves some parts from our RAM to the hard disk, then create some space to load the second application. It is called that particular mechanism is called virtual memory. Like that, there are some mechanisms in memory management. It is kind of vendor depends. That means the mechanism that you similar to that particular virtual memory. In Apple computer, it uses another system, another mechanism. Okay. Processor management. It has to provide the power of the processor for each and every process in the computer. So it need to be divided, or it need to be managed. Device management. All the devices, input, output, and storage, they need to be managed. And file management. You know that all the data is stored in a particular memory device as a file. They need to be managed. To manage them, we have to provide the file name, file type, and also encoding, decoding, conversion in a human readable, machine readable, like that. And also provide the security. Okay. Security means from maintaining the user accounts and providing the security for storage files for the operating system. Everything is security. To provide that, there are simple like backup, recovery, and by providing separate user accounts and mechanism to provide passwords, and also role based means creating roles and providing them their own authentication and authorization levels. Like, you know that in our computer there's a role called administrator. That administrator can perform many things. He can create users, install or uninstall applications, and also there are some other users, they only can use those applications. Sometimes they don't even have a chance to save their files. Sometimes some softwares, some installed applications, they are also restricted. Okay. That is a part of this security. And job accounting, another kind of complex thing. Control over system performance. That means something like this. Now you are using many softwares. Now computer is stuck or not responding. Now in that time, what we do is we are trying to close applications and we are going to load task manager, something like that. Okay. Now in that kind of situation, computer the freezing the interface or the desktop, it is also a kind of control over system performance. It means it temporarily freeze the interface to stop the user interaction while it resolve the problem. Okay. And interaction with the operators. To interact with the operations, when you're using the computer, in the computer we have to use applications, and we have to create files, we have to delete, rename, all those things. There need to be some mechanisms. By providing such solutions by using applications, simple like to name, rename, copy or cut a file, we use Windows it is an application provided by the operating system to handle files. Okay. Like that, generate interfaces, dialog boxes to interact with operators. To create a user account, there's an interface. In that interface, all the features need to be there, like create the username, change the password, and there to apply some restrictions, like, and error detecting, so that when you transfer files there may be some errors. If it has an error then operating system must have the capability of detecting it. And also sometimes it can be recovered or restored. If it can't, then it need to be reloaded. If it is downloaded from a remote location, then it need to be requested again. And coordination between other software and users. Now, after installing an operating system, we can't do many things. There are some legacy applications. Then that we have to install some other applications. Like here, we are going to use Office applications, so we have to install Office package. And to coordinate with that Office applications, this operating system must generate the interface, the windows, and by providing that, it will coordinate between the users, us, and the install applications or the softwares. And when we are going to install an operating system, first of all we have to select which operating system are we going to install. Okay. There are many types depending on their behavior, the commercial profile. Okay. These are the categories. First one is commercial, free and open source, and these are considering our requirement. Okay. And user interface, and requirement or compatibility, software availability, and stability. Okay. First one is commercial, Windows, Mac. That means most of the operating systems we have to buy them. Okay. Now we have to buy from that particular vendor, unless we have to install a pirate version. Okay. And free and open source, if you don't have enough money or the commercial strength to buy an operating system, then we can go for another solution called free and open source. It is Unix based or Linux based operating system. Nowadays it has all the solutions that can be provided by commercial based operating systems or Windows or Mac. These examples are Linux, Ubuntu, Debian, like that. CentOS. And user interface. User interface means something like this. Now in our day-to-day works we must have this interface called desktop, but some other systems like web server, we don't need an interface. A simple like graphical user interface like command prompt, it is more than enough. So if you don't need that kind of we don't have to use this kind of Windows operating system, so simply we can use this free and open source interface. And requirement or compatibility, that means you have a computer. Now you want when you're installing this operating system for that computer, first of all you must refer the system resources, the amount of RAM, hard disk capacity, the RAM, the CPU, because now we have most commonly we are using Windows 10. Now we can't install Windows 10 that manufacture in a computer that manufactured about 10 years ago. We can, but we have to do some upgrades. Okay. Like that, before installing operating system, we have to think about this compatibility or the requirement of the operating system. Then we can upgrade our computer, or we can consider our system resources available. Then we can find a compatible operating system. And software availability. Earlier when we talk about this free and open source operating system, the only problem is this software availability. Nowadays they have alterations for many softwares that uses in Windows operating systems. So let's say if you want to install AutoCAD, then most of the time you have to go for a Windows operating system. But for day-to-day works, then you can use free and open source operating system like Debian. Then we can install their Office package like OpenOffice, LibreOffice, like that. Okay, also keep in mind that for simple solutions, like let's say in your computer your Office package is expired. That means sometimes you can't create a new file, or you can't edit an existing file. So in that situation, instead of trying to find a serial or trying to install that Office package again, you can simply download free and open source Office package. They also provide kind of latest technology or the features available in those Windows based Office packages. And stable versions. Stability means when you are working this computer, if it seems like interrupts while you are working with some errors or or saying that need to be debugged or need to be updated, those are not stable versions. Stable versions does not need updates. Now this Windows 10, you can see that if you connect it with the internet, it frequently download new updates. That means it is not stable. And also if you run the task manager, you can see a process called system interrupts. Okay. If your computer kind of stuck, then you can see that system interrupts is at the top, consuming all the resources like RAM and CPU power, trying to resolve a problem. Okay. That is a feature, or not a feature, a characteristic of an unstable version. Unstable versions frequently crashes. That means you have to install, sometimes you have to install frequently or update. And these free and open source systems, they have many stable versions, many stable latest versions. So if it is not a kind of essential to use Windows uh, operating system, then better to use free and open source operating system like these. And application software, they are designed to do a kind of a specified task. It can be a kind of general purpose or particular specified. General purpose means something like this. Now you can you know that this office package, each and every, most of the time, 99 let's say all the personal computers, in all the personal computers you can see an office package is installed. Okay. That means it is kind of a general purpose software. And in supermarkets or any other institutions, you can see they have some sort of another set of software. Okay. They are called custom based or tailor made software. Okay. Now I have general purpose software, Microsoft Office Suite, Word, Excel, PowerPoint, Access, like. And we have OpenOffice. They will have a software similar to Word, another similar to Excel, like that. Also they are compatible with these files created by these applications. That means they also can be opened and modified in these applications. And web browsers, those are the software or application that we uses to browse internet, like Google Chrome, Firefox. Then graphic design, Adobe Collection, Photoshop, and also Corel Draw. And to edit video, Premiere. To create animations, Flash. And database, another special kind of application. Nowadays many things at the core of every system, there's a file called database. To manage that file, we need database management application like MySQL, MariaDB, Oracle. And in Office package we have access, OMS access, to create or modify or to manage database. And web servers, to convert to a computer into a web server, we need to install some application like this. So there are general purpose applications and custom made applications. And to create a custom made application, we have to meet a certain personalities called software engineer. And there are some institutions or companies that provide that solutions. We have to meet them and we have to present our requirement. Then they will fall in the solution. Those are the software that runs in that institutions and organizations like supermarkets and some office environments. Beside these office packages, they have a sort of system to provide services to the general community like us. A simple system is billing system and payroll system. And number systems, in a computer there are few number systems used. Now generally we use decimal number system. Base 10 uses 0 to 9 numbers to represent a number like this. And in a computer it uses binary number system. And also be familiar with this number system called hexadecimal system. The base is 16, uses numbers from 0 to 9, and also from 10 to 15 will be represented by these letters A, B, C, D, E, F, like this. And I mentioned this hexadecimal system because nowadays it used in this network field to address a computer. And also there are some codes like color codes that uses this hexadecimal system. So if you see something or a combination like this, most probably it can be a kind of a color code or any other set of data uses by the computer. That means by using this we can identify a number, also then that it can be a code to identify a color, and also it can be an address. And this is about history. This is the first computer, the second, third computer, the fourth one, and fifth. Now we are using after that one that computers can be divided into some types like this: personal computer, workstation, mini computer, mainframe, supercomputer. I mentioned these types because if you have the authority, or if you are in a place to buy a computer, this may be help you to identify the perfect computer for that situation, or the ideal computer for that. Nowadays we are using this personal computer for everything. If you need, want to create a web server, then you are using a personal computer. And for the office, personal computer. For video or graphic designing, they uses personal computer. But if you have the capacity or capability, there are some other solutions depending on the requirement. Personal computer is a single user computer system, moderately power micro processor, depending on that era. The moderate this powerfulness or the speed depends. And comparatively nowadays we have a higher powerful computers than the previous decade, and we uses this computer to for accounting, desktop publishing, office application, database management application, playing games, surfing internet, like that, for the general purpose. And this one, workstation, actually this is the real computer. Most personal computers, they are manufactured on bulk as bulk products. That means they are very vulnerable. Okay. After the warranty period, you can see that maybe you have to buy a new computer or you have to repair the computer. But in this workstation, it is a kind of stable computer, and also compatible. The compatible means the compatibility between the hardware devices, the processor, RAM, hard disk, motherboard, and all the other electronic devices. The compatibility is nearly 100%. But in personal computer, it doesn't have 100% compatibility. So since that compatibility is nearly 100%, it can perform it provide the stability. Okay. And this workstation, it is also a single user computer system. similar to personal computer but have more powerful microprocessor. Most of the time in personal computers, the processor is kind of an economical version. Now in this workstation, it is the real processor, kind of expensive, and it uses in this field engineering application like CAD and computer aided design, computer aided manufacturing, desktop publishing, software development. It has high resolution screen. Nowadays we also have high resolution screen on personal computer, but it provides additional features and mass storage. And the price, if you compare personal computer and workstation, about the price tag, it's about 3 times expensive than personal computer. That's the reason. Okay. So next one is mini computer. It is a multi-user computer system. Let's say for an office environment, if instead of providing this personal computers for each and every person, we can buy a single server and provide these components for each personnel. By using this one, they can build on your own interface. Okay, by this we can provide their own interface, and also they can share the same server. And this one is ideal for an environment like a library. And mainframe computer, to maintain a system like banking system and web services like email account server, we must have a larger or sophisticated computer system. So for that they uses mainframe computers. It's a multi-user computer system, and it has the capability of providing support thousands or millions of users simultaneously nowadays. And the software technology is different from mini computer. It has a kind of load sharing or many set of mechanisms to provide the service for the users. Okay. Now examples for like banking systems. Okay. And the last one is supercomputer. It's a very fast computer. Now that mainframe system is kind of separate set of computers which runs the same system in each and every computer. It provides services depending on the number of users. But the supercomputer is a single computer. It has extremely fast. Okay. And also in uses in kind of fields like specialized fields like research for weather forecasting, scientific simulations, and for these like fluid dynamics, for physics experiments, nuclear energy research, electronic design, analysis, like that. And these are the kind of the supercomputers in the modern world. Sometimes the performance may be adjusted. And in China we have a Sunway Twilight. It has this number of processors, and the speed is 93,000 teraflops. Flops mean floating point operations. Floating point means the numbers with decimal places. You know that when you are dealing with numbers with decimal places, you have to be pay the attention for that decimal place. After adding, dividing, multiplying, then you have to uh, decide where to put that decimal point. Okay, like that. uh, this is not the traditional speed mention scale, sorry, this is not the traditional scale to that scale to mention the speed of the computer. It is gigahertz, but here it says teraflop, floating point operations. Like this, there's a list of supercomputers. You can find many information on internet on this. Okay, those are about the fundamentals of the computer and about history and computer types.